Welcome back, everybody. Ready for another deep dive?
Absolutely. Always ready to dive in.
Well, today we're going to be looking at subsymbolic AI.
Sounds fascinating.
Yeah, this is based on an essay by Jörg-Owe. And basically, it's about how we build AI, not using sort of the old way with hard-coded rules and logic.
Oh, interesting.
Yeah, it's more about, data, letting computers learn from data.
Okay, so how's that work?
I guess kind of like instead of telling a computer how to bake a cake step by step,
Right.
we give it a ton of recipes
And
let it kind of figure it out on its own.
Interesting. So it's about finding patterns, right?
Exactly.
In data.
Yeah. Maybe patterns that even we wouldn't notice.
And then using that to solve problems.
Yeah. Solve problems, make predictions, kind of understand the world in a new way.
So it's almost like teaching a computer to think more like us.
Yeah, I guess you could say that.
But with the advantage of processing huge amounts of information.
Yeah, at speeds that we can't even imagine.
Right.
Now, Schneeppert talks about a bunch of different techniques that kind of fall under this subsymbolic AI umbrella.
Okay.
And one of the ones that I always find really interesting is artificial neural networks.
Oh, yeah. Those are fascinating.
Because they're inspired by, how our brains work.
Exactly. That's what makes them so intriguing.
Yeah.
They're designed to mimic how our own brains process information.
So how do they actually work?
Well, they're basically networks of interconnected nodes, almost like a web. And they work together to learn from data.
Okay.
And each connection between those nodes has something called a weight.
Right.
And during the learning process, those weights are adjusted.
So that the network can identify patterns.
Exactly.
Okay. So it's not like we're programming it with rules.
No, it's learning through experience, much like we do.
Like we do. And this can be applied to so many things. Image recognition, understanding language.
Absolutely.
It's incredible.
It is. Another interesting technique is fuzzy logic.
Fuzzy logic.
Yeah, and this one's really good at dealing with uncertainty.
Okay.
Imprecision.
So things that our traditional logic systems can't always handle.
Exactly. It's more nuanced.
Okay.
It allows computers to deal with those gray areas of decision making.
So it's kind of like how we make decisions in the real world, right?
Yeah.
Because we don't always have all the information.
Precisely. We rely on intuition, on our past experiences. Fuzzy logic lets computers do the same.
So instead of just saying a fruit is ripe or unripe,
Right.
we could say it's like 70% ripe.
Exactly. That kind of flexibility is really valuable.
Yeah. Now, Schneeppert also talks about genetic algorithms,
Oh, yes.
and those seem to be inspired by nature.
They are, very much so. They're based on the principles of evolution,
Okay.
natural selection.
Survival of the fittest, kind of.
In a way, yes.
So how do those work?
Well, you create a population of potential solutions to a problem, and then you use processes like selection,
Okay.
crossover, mutation
Okay.
to evolve those solutions over time.
And eventually you get to like the most optimal solution.
Exactly. The fittest solution survives.
And so these have been used in engineering and finance.
And even art
Oh, wow.
to create designs. And then there's swarm intelligence,
Swarm intelligence.
which is based on the collective behavior of decentralized systems.
Okay. What does that mean?
Think about a colony of ants
Okay.
or a flock of birds.
Right.
Each individual has simple rules.
But as a group.
As a group, they create complex behavior.
So the whole is greater than the sum of its parts.
That's a great way to put it.
And this is used for like coordinating robots in a warehouse.
That's one example, yes. Traffic flow.
Oh, interesting. Anything where you need distributed decision making.
Exactly.
Now, we can't talk about powerful approaches without mentioning deep learning.
Yes. Deep learning, that's a hot topic.
That's all the rage these days.
It is, for good reason. It's a subfield of machine learning where we use these artificial neural networks,
Okay.
but with multiple layers.
So it's like neural networks on steroids.
You could say that. They can learn really complex patterns.
And that's why we get self-driving cars.
That's one application, yes. Medical diagnosis. It's really powerful.
It's amazing how far deep learning has come.
It is. But it's important to remember it's just one tool
Right.
in the Subsymbolic AI toolbox.
Now, Schneeppert also talks about a couple other techniques, inductive logic programming
Yes.
and neurosymbolic systems. Those sound pretty interesting, too.
They are. Inductive logic programming combines logic programming with statistics.
Okay.
It learns rules from data.
So instead of giving the computer rules, it learns them.
Exactly. And neurosymbolic systems are really fascinating. They try to combine the best of both worlds.
So the symbolic AI
Yes.
and the subsymbolic AI.
Exactly. So you get AI that can reason logically and learn from experience.
Wow.
It's a powerful combination.
It sounds like it. So just to kind of recap here,
Sure.
we've talked about artificial neural networks,
Yes.
fuzzy logic,
Right.
genetic algorithms, swarm intelligence,
Deep learning.
deep learning, inductive logic programming, neurosymbolic systems. Wow.
Quite a toolbox.
Each of these techniques offers a unique way to use data and computation to solve problems.
And to achieve intelligent behavior.
Exactly. So now that we have a handle on some of the key techniques,
Yes.
let's move on to how subsymbolic AI is being used in the real world.
So subsymbolic AI is making a big impact in a bunch of industries already. Schneepat talks about some real-world applications that are really changing things up.
Yeah, it seems like every day there's a new headline about AI doing something incredible. Like, how do you even keep up with it all?
It is moving fast, that's for sure. One area where we're seeing huge progress is healthcare.
Oh, that's an area I'm really interested in. I've heard about AI being used to, diagnose diseases, come up with treatment plans. Is that kind of what Schneepat's getting at?
Yeah, exactly. Like, they're using AI to look at medical images.
Okay.
X-rays, MRIs. And it can help doctors spot diseases way earlier.
And more accurately.
Much more accurately. And there are even systems that can go through tons of patient data, like mountains of it,
Wow.
to find patterns and predict health risks.
So it's really becoming a powerful tool for doctors and nurses.
It really is. Potentially saving lives.
Yeah. Wow.
But healthcare is just the tip of the iceberg. Schneepat also talks about how it's being used in finance.
Oh, okay. In what way?
Well, things like fraud detection, risk assessment.
Yeah.
Finance deals with so much data.
Right. Yeah.
It's always looking for ways to improve security and efficiency.
Makes sense.
So you have these AI algorithms that can analyze transactions like super fast,
Okay.
catch anything suspicious, and then they can also, assess credit risk and make loan decisions more efficiently.
So it's not just about, stopping bad stuff from happening. It's also about making the whole system work better.
Exactly. And it can even make financial services more accessible.
Oh, interesting.
Yeah, AI is also transforming other areas like e-commerce and marketing.
Oh, yeah. How so?
Well, it's being used to personalize those recommendations, you see. Optimize pricing.
Okay.
Target advertising more effectively. So basically, it's all about connecting businesses with their customers in a more personalized way.
Yeah. It seems like AI is everywhere these days. Now, Schneepat also mentioned something about applications in agriculture and environmental solutions.
Oh, yeah. That's a really exciting area.
What's AI doing in those fields?
Well, in agriculture, it can help optimize crop yields, monitor soil conditions, even detect pests and diseases really early on.
Wow, so that can help farmers be more efficient, reduce costs.
Exactly. And it can also contribute to a more sustainable food supply.
Yeah, so AI could actually help address global challenges like food security.
It definitely has that potential. And in the environmental realm, AI can help monitor deforestation, track wildlife, even develop better renewable energy systems.
That's amazing. It seems like subsymbolic AI has the potential to, solve so many problems we're facing. But Schneepat doesn't just focus on the positives, right?
No, he doesn't. He's also upfront about some of the limitations.
Yeah, because no technology is perfect. What are some of the drawbacks he mentions?
Well, one of the biggest ones is this lack of transparency, especially with things like deep learning.
Oh, you mean the black box problem?
Exactly. We don't always know how these systems are making their decisions.
Right. Even if they're super accurate, we can't always explain the why.
Right. And that can be a problem in fields like healthcare and finance, where those decisions can have really big consequences.
Yeah, it's understandable that people want to know why a machine made a particular decision, especially when it affects their lives.
Absolutely. Another challenge is this dependence on huge data sets.
Right.
Subsymbolic AI, especially deep learning, needs a ton of data to learn.
So if you don't have the data,
Then even the best algorithm is going to be limited.
so data is key.
Data is absolutely essential.
Now, Schneepat also mentions that subsymbolic AI might not be the best for everything, like tasks that need strict logic.
That's a good point. It's great at pattern recognition, learning from data.
Right.
But if you need something that can reason symbolically or handle abstract concepts.
It might not be the right tool.
Exactly. So it's really about understanding the strengths and weaknesses of each approach.
And choosing the right tool for the job. So we've talked about the techniques, the real-world uses, and some of the limitations. What does Schneppat say about what's next for subsymbolic AI?
Well, he believes it's going to continue to play a huge role in shaping our future. And he points to some key areas of research that are going to drive the field forward. He talks about interpretability. Researchers are really working on making these AI systems more transparent.
Okay, so especially for like deep learning.
Yeah, where we have that black box problem.
Right, so it's about making AI more understandable.
Exactly. Not just what it does, but how it gets there.
Yeah, because as AI gets more powerful and we start using it for more things.
We need to be able to trust its decisions.
Exactly. What else is Schneppat looking at?
Well, robustness is another big one.
Robustness.
Making these systems more reliable, less likely to make mistakes.
Or be biased.
Right, especially when you're using AI in the real world.
Yeah, because the real world's messy.
It is. You need AI that can handle that. And then efficiency is another key area.
Okay, so making them faster.
Faster, less energy hungry.
So?
Because we're dealing with more and more data all the time.
Yeah, and AI is becoming more and more part of our lives.
Exactly.
So it can't be like slowing everything down.
Right. Schneppat also talks about how important collaboration is going to be.
Oh, okay.
Bringing together people from different fields, computer science, neuroscience, even philosophy.
Wow. So it's not just about the tech itself.
It's about understanding intelligence in a broader sense.
That's fascinating.
Yeah, by bringing all those perspectives together.
We can build better AI.
More robust, more interpretable, more beneficial.
Well, this has been a really interesting deep dive. We've covered a lot. The different techniques, how subsymbolic AI is being used, what the future might hold. Any final thoughts for our listeners?
I think the main takeaway is that subsymbolic AI is incredibly powerful, and it's changing the world as we speak.
Yeah, it's not just science fiction anymore.
It's here, it's now, and it's going to keep evolving. But it's not just one thing. There are so many different approaches, each with its own strengths and weaknesses.
So we need to be thoughtful about how we develop and use it.
Absolutely, because ultimately, AI is a tool.
Right.
And it's up to us to decide how we use it.
To make sure it's used for good.
Exactly.
Well, a big thank you to Jörg-Owe for his essay that really sparked this discussion. And to our listeners, thanks for joining us. We hope you found this deep dive into subsymbolic AI insightful. Until next time, keep exploring.